close your eyes and let yourself settle into comfort. Tonight, we're going to explore something remarkable, something that millions of people watch each year, but few truly consider. Tonight, we'll journey into the engineering, the artistry, the precision, and the beauty of the Times Square ball. Let your breathing slow, deep and easy, in through your nose, out through your mouth. There's nowhere to be except here, nothing to do except rest and listen. Picture Times Square on New Year's Eve, a million people packed into tight spaces, shoulders pressed against shoulders, cold air, bright lights everywhere, screens towering above, and high overhead, barely visible among all the chaos, a sphere, 12 feet in diameter, nearly 6 tons of weight, suspended 470 feet above the street, waiting. For 364 days of the year, it sits there, mostly unnoticed, just another fixture in the overwhelming sensory assault that is Times Square. But for one night, for 1 minute, for 60 seconds, it becomes the center of the world. The Times Square Ball. Let your muscles relax. Let your jaw unclench. Let your tongue rest soft in your mouth. We're going to spend time with this ball, going to understand it, going to see how engineering and art and tradition combine into this one spectacular moment, and in understanding it, in dwelling in these technical details, in appreciating the precision and care and craftsmanship, you're going to drift, going to relax, going to sink into the peaceful state where information becomes meditation, where facts become a gentle lullaby. The ball is covered in 2,688 Waterford Crystal triangles, each one precisely cut, each one unique, each one catching light in its own way. The crystals are arranged in a pattern, a geodesic sphere, mathematical, perfect, beautiful. Inside the crystals, 32,256 LEDs, light-emitting diodes, tiny semiconductors that convert electricity to light with remarkable efficiency. Each LED can produce millions of colors, can be controlled individually, can create patterns, waves, pulses of light that dance across the sphere. But we're getting ahead of ourselves. Let's go back. Back to the beginning, back to when there was no ball at all. New Year's Eve, 1904. Times Square, then called Longacre Square, is celebrating the opening of the New York Times Tower, the tallest building in the city at that moment. The Times wanted to mark the occasion spectacularly, so they set off fireworks from the roof. It was magnificent, dangerous, but magnificent. The crowds loved it, and so it became a tradition. Each New Year's Eve, fireworks over Times Square. But by 1907, the city had banned fireworks in the square. Too dangerous, too many people, too much risk. So the Times needed a new way to mark midnight, a new tradition. Someone suggested a ball drop, not an original idea. For centuries, time balls had been used in harbors, large spheres that would drop at a specific time, allowing ship captains to set their chronometers. Greenwich Observatory had one. Liverpool, Plymouth, even New York Harbor had one. The concept was simple, a visible signal, something everyone could see. That would mark an exact moment in time, perfect for midnight on New Year's Eve. Breathe slowly. Let your breath be like the descent of that first ball. Smooth, steady, inevitable. A metal worker named Jacob Starr was commissioned to build it. He had a shop on the street level of the Times Tower, And in late 1907, he created the first Times Square ball. It was 5 feet in diameter, made of iron and wood, heavy, solid, and decorated with 125-watt light bulbs. Electric lights were still relatively new, still magical. A sphere covered in light bulbs was spectacular. On December 31st, 1907, the ball was hoisted to the top of the flagpole on the Times Tower. At 1 minute before midnight, it began to descend, slowly, taking the full 60 seconds to reach the bottom. The crowd watched, counted 10, 9, 8, and when the ball reached bottom, when the year changed, they erupted, cheered, celebrated. A new tradition was born. That ball served for 7 years, from 1907 to 1914. Through those years, Times Square was establishing itself as the place to be on New Year's Eve. The ball drop was becoming iconic, but the ball itself needed updating. In 1920, a new ball replaced the original. 400 pounds of iron, still 5 feet in diameter, still lit with 100 light bulbs, but more refined, more elegant, more substantial. This ball lasted over half a century, through the Roaring Twenties, through the Great Depression, through World War signs when it didn't drop in 1942 and 1943 because of the wartime blackout, through post-war prosperity, through the 1950s and 60s, through cultural upheaval. The same ball, year after year, descending, marking time, bringing people together in that one moment of transition. Let yourself feel the continuity of that, the same ritual, the same descent, year after year, decade after decade, anchoring people to time, giving them a moment to share, to count down together, to welcome the new year together. Your body is so relaxed now, heavy, comfortable, like the weight of that iron ball, grounded, stable, at rest. In 1955, the ball was renovated, made lighter, aluminum now instead of iron, still 5 feet in diameter. The technology of lighting had improved. Strobes were added. The ball could pulse with light, could flash, could create drama at the moment of midnight. This aluminum ball served until 1995. 40 years. Generations of people watched this ball drop. It became part of the cultural fabric, part of the collective experience of being American, of celebrating, of marking time. By the 1990s, though, it was showing its age, and technology had advanced dramatically. The organizers wanted something better, something that would reflect the approaching new millennium, something spectacular. In 1995, a new ball debuted, the Millennium Ball, though it would actually be used for 5 years before the millennium arrived. This ball was 6 feet in diameter, larger than its predecessors, made of aluminum, rhinestones and strobes and mirrors. It weighed 1,070 pounds. It was beautiful in its way, sparkly, flashy, very 1990s. It served from 1995 to 1998, each year descending, each year bringing that moment of transition, that countdown, that collective breath held and then released. But something bigger was coming. The year 2000, the millennium, Y2K. The whole world was focused on this transition, and Times Square, the ball drop, was going to be the center of it all. They needed a ball worthy of the moment. Breathe in anticipation. Breathe out preparation. Let yourself drift with these stories, these iterations, these improvements, building on improvements. For the Millennium Celebration, they created something special. A ball 6 feet in diameter. Crystal. Rhinestones, 600 pounds. Covered in Waterford crystal triangles, 504 of them. Each one hand cut in Ireland. Each one unique. The triangles bore different patterns. Some were cut with the pattern, "Let there be light." Others with "Hope for fellowship," "Hope for wisdom," "Hope for tolerance," "Hope for peace," "Wishes for the new millennium," aspirations, hopes, cut into crystal and displayed on a sphere that the world would watch. Inside the crystals, halogen bulbs and computer controls that could create changing patterns of light, red to white to blue, pulsing, rotating. The ball could tell a visual story as it descended. New Year's Eve, 1999. 2 million people in Times Square. A billion more watching on television around the world. All eyes on this sphere. This 6 feet of crystal and light and engineering. The countdown began. 10, 9, 8. The ball started its descent. 70 feet, taking 60 seconds. Smooth, steady. 7, 6, 5. The crowd counting together. 4, 3, 2, 1. The millennium arrived. The ball reached the bottom. Fireworks exploded. Confetti fell. People kissed and cheered and cried. And the Waterford Crystal Ball had done its job, had marked the moment, had brought everyone together in that instant of transition. That ball served for 7 more years, through the early 2000s, through September 11th and its aftermath, through wars and peace, prosperity and recession, joy and sorrow. Each year the ball dropped. Each year the moment arrived. Each year time turned. Let your breathing turn like the years turn. Steady, reliable. Each breath following the one before. Each breath leading to the one after. The cycle continuing. But technology was advancing. LED technology especially. Light-emitting diodes had become bright enough, efficient enough, colorful enough to replace other lighting technologies. And someone had a vision of what the Times Square ball could become. In 2007, for the 100th anniversary of the first ball drop, a new ball was designed. The ball that still hangs in Times Square today, with some updates and improvements, but fundamentally the same ball that has dropped every year since 2007. This ball was different, larger, more complex, more capable, more beautiful. 12 feet in diameter, twice the size of the Millennium Ball, weighing 11,875 pounds, nearly 6 tons, a massive sphere of metal and crystal and light. The engineering required to support this weight, to move it smoothly, to control it precisely, to ensure it never failed, never fell, never malfunctioned. That engineering is remarkable. Let's explore it. Let's understand how this ball works. And as we do, let yourself sink deeper into relaxation. Let the technical details wash over you. Let them become a meditation on precision, on care, on the human desire to create something perfect. The ball is built on an aluminum frame, a geodesic structure, triangles connecting to form a sphere. This design, popularized by Buckminster Fuller, is remarkably strong. The triangle is the strongest shape in engineering. It can't be deformed without changing the length of its sides. So, a structure made of triangles is inherently rigid and stable. The ball's frame consists of 672 LED modules. Each module is a triangle. Each module contains 48 LEDs. That's where the number 32,256 comes from. 672 multiplied by 48. These modules are attached to the aluminum frame, bolted securely, wired carefully, each one positioned precisely so that the sphere maintains its perfect shape, 12 feet in diameter, an exact hemisphere at the top, an exact hemisphere at the bottom, meeting at the equator. The frame is designed to handle the weight, the stress, the forces involved in supporting nearly 12,000 pounds suspended 470 feet above the street. Engineers calculated load factors, safety margins, worst case scenarios. They over engineered it deliberately because failure is not an option. Imagine the responsibility, knowing that millions of people are watching, that this ball must work perfectly, that there's no backup, no second chance. If the ball fails to drop, or drops wrong, or malfunctions in any way, the whole event fails. The whole tradition breaks. So everything is checked, double checked, triple checked, tested rigorously, maintained constantly. Nothing left to chance. Breathe in reliability. Breathe out anxiety. Let yourself trust in the engineering, in the care, in the precision. The frame is mounted on a pole that extends from the roof of 1 Times Square. The building itself is not particularly tall anymore. It was once the tallest, but now it's dwarfed by its neighbors. But it's still the symbolic center of Times Square, still the place where the ball hangs. The pole is engineered to handle the weight and wind loads. Times Square is a wind tunnel. Buildings create channels that accelerate wind. Gusts can be strong, unpredictable. The pole and the ball must withstand whatever nature throws at them. The ball hangs from a motor system. This system serves 2 purposes. 1, it supports the ball's weight continuously. 2, it controls the descent on New Year's Eve. The motor is manufactured by Turnbull, an American company that specializes in this kind of precision machinery. The system uses a cable and pulley arrangement. The ball is suspended from a steel cable. The cable runs through pulleys to a motorized winch. For most of the year, the cable holds the ball at its highest position, 470 feet above the street. The motor is locked, the brake engaged. The ball just hangs there, motionless, waiting. But when it's time to drop, the motor engages, the brake releases, and the ball begins to descend. The descent is controlled by a computer, a program that manages the motor's speed with extraordinary precision. The ball must drop exactly 70 feet, must take exactly 60 seconds, must arrive at the bottom at exactly midnight, 70 feet in 60 seconds. That's 1.167 feet per second, about 14 inches per second. Slow enough to see clearly, slow enough to build anticipation, slow enough for 1,000,000 people to count down together. The computer monitors the descent continuously, checks position, adjusts speed if needed, ensures that the ball arrives on time, not a second early, not a second late. Exactly at midnight according to the official atomic clock signal. Let yourself imagine the precision required, the calibration, the testing, engineers spending hours fine-tuning the program, running simulations, adjusting parameters, all for 60 seconds of performance once a year. Your heartbeat is precise too, regular, reliable, about 60 beats per minute when you're at rest, each beat timed perfectly, each beat maintaining your life without conscious effort. Your body is an engineer of remarkable precision. The cable that supports the ball is inspected regularly, checked for wear, for fraying, for any sign of weakness. If there's any question about its integrity, it's replaced. No risks taken. The pulleys are lubricated, bearings checked, mechanical systems maintained. Everything that moves is tested. Everything that supports is verified. Behind the scenes, there's a crew of technicians, electricians, engineers, people who know this ball intimately, who understand every component, every connection, every potential failure mode. They work year round. Maintenance in spring, updates in summer, testing in fall, final preparations in December, and on New Year's Eve, they're there, in the control room, monitoring, ready to respond to any issue, making sure that when midnight comes, the ball drops perfectly. It's easy to take for granted. You watch it on TV or in person, and it seems simple. A ball drops. But behind that simplicity is enormous complexity, enormous care, enormous expertise. Let yourself appreciate that. The invisible work that makes visible spectacle possible. The preparation that allows performance. The maintenance that ensures reliability. Rest in the knowledge that there are people everywhere making things work, making things happen, caring for systems and structures that you depend on without knowing it. The world runs on the accumulated competence of millions of people doing their jobs well. And tonight, you don't have to do anything. You can just rest, just be, just appreciate, just breathe. Now, let's talk about the surface of the ball, the 2,688 Waterford Crystal triangles that cover it, making it sparkle, making it beautiful, making it more than just a technological device, making it art. Waterford is a city in Ireland. For over 200 years, it's been famous for crystal, for cut glass of exceptional quality and beauty. The company Waterford Crystal has been making luxury crystal pieces since 1783. Bowls, vases, chandeliers, items that catch light and transform it into something magical. When the designers of the 2007 ball wanted crystal, they went to Waterford, asked them to create triangles. Not just any triangles. These would be seen by millions, would be photographed and filmed and broadcast worldwide. They had to be perfect. Waterford assigned their master craftspeople to the project. In their factory in Ireland, skilled workers began the process of creating these crystals. It starts with glass, high quality glass with a high lead content. Lead crystal, it's called, though modern formulations often use other elements. The lead, or its substitute, gives the glass extra clarity, extra weight, extra ability to refract light. The glass is melted in furnaces, heated to over 2,000 degrees Fahrenheit, molten, glowing. Then it's formed into flat sheets, thick sheets that will be cut and polished. Once the sheets cool, the cutting begins. This is where artistry meets precision. Waterford crystals are cut with patterns, grooves, facets, angles that catch light and break it into rainbows. For the Times Square ball, they created multiple designs. Each triangle has a pattern. Some have the traditional Waterford cuts, lines radiating from the center, concentric circles, geometric patterns. Others have special designs, representations of hope, celebration, wishes for the new year. The cutting is done by hand and machine working together. A craftsperson guides a piece of crystal against a rotating wheel. The wheel is coated with abrasive. As the crystal presses against it, material is removed. A groove forms. A facet emerges. It requires skill, judgment, feel. Too much pressure and the crystal cracks. Too little and the cut is shallow. ineffective. The craftsperson must know exactly how hard to press, exactly what angle to hold, exactly how long to cut, and they must do it consistently. Each triangle must meet specifications, must be the right size, the right shape, must have its pattern cut to the right depth, because these triangles have to fit together perfectly on the ball. Any variation and gaps appear, or triangles overlap, or the sphere becomes imperfect. Let your breathing be like the cutting, steady, practiced, precise, each breath exactly as deep as it needs to be, no more, no less. After cutting, the crystals are polished. This removes any roughness left by the cutting wheel, brings out the clarity, the transparency, the ability to transmit and refract light. Polishing is done with progressively finer abrasives, starting coarse, ending fine. The crystal is pressed against polishing wheels coated with compounds. Each pass makes the surface smoother, more reflective, more beautiful. The final polishing is done with rouge, a fine powder of iron oxide. It creates a surface so smooth it's essentially flawless. Light entering the crystal passes through without distortion, exits at precise angles, creates the sparkle that crystal is known for. Each triangle is then inspected, held up to light, examined for flaws, for bubbles in the glass, for irregularities in the cuts, for any imperfection. The standards are high. Any triangle that doesn't meet them is rejected, set aside, can't be used on the ball. Only perfect crystals make it to Times Square. Imagine the care that goes into each one, the attention, the decades of skill accumulated by the craftsperson, all focused on making this one triangle perfect, and then multiply that by 2,688. That's how many perfect triangles had to be created. The triangles are shipped to New York, carefully packed, each one protected. They're irreplaceable. Can't just order more quickly if one breaks. Each triangle is precious. In New York, they're attached to the LED modules. Each LED module has a crystal triangle mounted on it. The crystal sits in a frame, held securely but not too tightly. Glass is rigid but also brittle. Too much force and it cracks. The mounting system has to secure the crystal while accommodating thermal expansion. Temperature changes cause materials to expand and contract. The mounting allows for this without stressing the crystal. The alignment is critical. Each triangle must sit flush with its neighbors. The geodesic sphere must be continuous, smooth, no gaps, no overlaps, perfect geometry. Workers use templates, measuring tools. They check and double check. Each triangle positioned precisely. Each mounting verified. It takes time, patience, care. But when it's done, when all 2,688 triangles are in place, the result is breathtaking. A sphere of crystal, catching light from every angle, refracting it, multiplying it, creating a shimmer that can be seen from blocks away. During the day, the ball hangs there, catching sunlight, sparkling, a jewel suspended in the sky. At night, with the LEDs illuminated, it becomes something else, a sphere of light, of color, of energy. The crystals don't just cover the LEDs, they transform them. Light from an LED is directional. It comes out in a cone, but when that light passes through cut crystal, it's bent, scattered, reflected internally. It emerges from the crystal in multiple directions. The crystal takes a point of light and turns it into 1,000 points of light. That's why the ball is so visible. So brilliant. The LEDs provide the light, but the crystals multiply it. Make it spectacular. Make it art. Let yourself see it in your mind, this sphere of crystal and light, hanging high above Times Square, waiting, ready, beautiful even in stillness, beautiful even in waiting. Your eyes are so heavy, so relaxed, you don't need to see anything, just darkness, soft, peaceful darkness behind your closed lids. Now, let's go deeper into the light itself. The 32,256 LEDs that illuminate the ball from within, that create the colors, the patterns, the life of the ball. LED stands for light emitting diode. A diode is a semiconductor device. It allows electricity to flow in one direction, but not the other. When electricity flows through a diode made of certain materials, it emits light. That's an LED. The technology has existed since the 1960s, but early LEDs were dim, only red, not useful for much beyond indicator lights on electronics. But over decades, researchers improved them, made them brighter, created new colors. Blue LEDs were particularly difficult. Took until the 1990s to develop properly. The scientists who figured it out won the Nobel Prize in Physics in 2014. Once you have red, green, and blue LEDs, you can create any color, just like pixels on a screen. Mix red and green, you get yellow. Red and blue make magenta. Green and blue make cyan. All three together make white. Different intensities create different shades. Each LED module on the ball contains 48 LEDs, and each LED is actually 3 diodes in one package: red, green, and blue. So each LED can produce millions of colors depending on how much power is sent to each of the 3 diodes. These are controlled by a computer system. The designers create patterns, programs, sequences of colors that flow across the ball. The computer sends signals to each LED, telling it what color to display and how bright. The control system is sophisticated. It has to manage 32,256 LEDs simultaneously, has to update them quickly enough that motion appears smooth, has to ensure that colors are accurate, that brightness is consistent. The LEDs are Philips Luxian Rebel LEDs, manufactured by Lumileds, a lighting company. These are high-power LEDs, bright, efficient, reliable. Each one can produce over 100 lumens. Together, the ball can emit over 3 million lumens, bright enough to be seen from miles away. Lumens measure light output, the total amount of visible light emitted. For comparison, a typical 60-watt incandescent bulb produces about 800 lumens. So, the ball produces the equivalent of about 3,750 incandescent bulbs, all from LEDs that consume far less power. Power efficiency is important. The ball runs on electricity. That electricity has to be supplied. Cables running up the building, connections to the electrical grid, transformers, circuit breakers, all the infrastructure needed to power 32,256 LEDs. LEDs are much more efficient than incandescent bulbs or even fluorescent lights. They convert about 50% of electrical energy into light. The rest becomes heat. That's actually remarkably good. Incandescent bulbs convert only about 5% to light. The rest is heat. But still, with this many LEDs at this brightness, the ball generates heat. Quite a bit of heat. Engineers had to design cooling systems, heat sinks, airflow, ways to dissipate heat so the LEDs don't overheat and fail. The LED modules are designed with thermal management in mind. metal backing to conduct heat away from the diodes, spacing to allow air circulation, temperature sensors to monitor conditions. On New Year's Eve, with all the LEDs at full brightness for extended periods, the ball gets warm, not hot enough to be dangerous, but warm. The cooling systems work constantly to maintain safe temperatures. Breathe in cool air, breathe out warm air. Your body is a thermal management system too, maintaining 98.6 degrees Fahrenheit regardless of external conditions. Cooling when necessary, warming when necessary, all automatically. The LEDs are wired in series and parallel combinations. This distributes the electrical load, provides redundancy. If one LED fails, others continue working. The pattern might be affected, but the ball doesn't go dark. Actually, LED failure is rare. These diodes are rated for 50,000 hours of operation. That's about 5.7 years of continuous use. Since the ball only operates for special occasions and testing, the LEDs should last decades. But they're monitored. Each module reports its status. If an LED fails, technicians know. They can replace the module. The ball is designed for maintainability. Modules can be swapped out without disassembling the whole structure. The patterns displayed on the ball are created by lighting designers, artists who work in light. They use specialized software to design animations, colors flowing across the sphere, spirals, waves, pulses, geometric patterns, representational images. For New Year's Eve, the sequence is carefully choreographed. As the ball descends, the lights change, building excitement, creating drama. The patterns accelerate, the colors intensify, and at midnight, at the moment the ball reaches bottom, the lights explode into brilliant white, full brightness, all LEDs on, a sphere of pure light. It's breathtaking. Millions of people watching, and at that exact moment, the ball is the brightest thing in Times Square, outshining even the massive LED screens on the surrounding buildings, a sphere of light marking the transition of time. The computer controlling the lights is synchronized with the motor controlling the descent. They work together, perfectly timed. The visual display matches the physical movement, the two elements combining into one coherent experience. This synchronization requires precise timing. Computer clocks are accurate to milliseconds, but even milliseconds matter. If the lights reached their climax a second early or late, it would feel wrong. Anticlimactic. The timing has to be perfect, so the system is calibrated against official time signals. The United States Naval Observatory maintains the master clock for the country, using atomic clocks that are accurate to nanoseconds. This official time is broadcast. The ball's control system receives it, stays synchronized. On New Year's Eve, the ball's computer knows exactly when midnight will arrive, knows exactly how long the descent will take, can calculate exactly when to begin, exactly what speed to maintain, exactly when to trigger the final light display. And year after year, it works. The ball drops, the lights shine, the moment happens, precisely, perfectly, because engineers and technicians and artists have prepared it, have tested it, have made it work. Let yourself appreciate the layers of expertise required. Electrical engineers designing circuits, software engineers writing programs, lighting designers creating art, mechanical engineers building structures, all working together, all contributing their piece, all making the whole possible. You don't have to understand every detail. You don't have to remember any of this. Just let it wash over you. Let it remind you that the world is full of people doing remarkable things. creating beauty, creating precision, creating shared experiences, and you can rest in that world, can trust it, can close your eyes and know that tomorrow the sun will rise, systems will function, people will do their jobs, and life will continue. Rest now. Sink deeper. Let the technical details fade into background. Let sleep approach. The mechanism that lowers the ball is a marvel of mechanical engineering, simple in concept, but precise in execution. Let's explore how it works, how a 6-ton sphere descends 70 feet in exactly 60 seconds, without jerking, without swaying, without variation. The ball hangs from a steel cable. The cable is made of braided wire, multiple strands twisted together. This provides strength and flexibility. A solid rod of the same diameter would be stronger, but too rigid, could snap under sudden loads. Braided cable can flex slightly, can absorb shocks, can handle the forces involved. The cable runs from the top of the ball through a hole in the roof structure to a motor room. In that room is the winch system. The cable wraps around a drum. The drum is connected to a motor through a gearbox. The motor is electric, powerful but controllable. Electric motors can be precisely regulated, can hold specific speeds, can start and stop smoothly. This is essential for the ball drop. The gearbox reduces the motor's speed. Motors typically run at thousands of revolutions per minute, far too fast for lowering the ball. The gearbox steps this down, might be 100 to 1 or 1000 to 1. For every 1,000 rotations of the motor, the drum rotates once. This gives enormous control. The motor can run at its efficient speed, and the drum turns slowly, smoothly, at exactly the rate needed. There's also a brake, a mechanical brake that can stop the drum instantly if needed. Normal operation, it's released during the descent. But if there's an emergency, if something goes wrong, the brake engages. The ball stops, held safely by the brake until the issue is resolved. Safety systems are layered, redundant. The cable is rated for far more weight than it will ever carry. The motor has multiple fail-safes. Power loss triggers the brake automatically. The ball can't fall, can't fail catastrophically. The drum has sensors monitoring its rotation, optical encoders that track position precisely. As the drum turns, the sensors count. They know exactly how many degrees the drum has rotated. From that, they calculate how far the ball has descended. This position data feeds back to the computer. The computer compares actual position to expected position. If the ball is ahead or behind schedule, the computer adjusts motor speed, speeds up slightly, or slows down slightly, keeps the descent on track. This is called a feedback loop, a fundamental concept in control systems. You measure what's happening, compare it to what should be happening, adjust to minimize the difference, continuously, hundreds of times per second. The result is smooth motion, consistent speed, arrival at the bottom at precisely the right moment. Breathe in smooth descent. Breathe out any tension. Let yourself feel the controlled fall, the gentle lowering, like sinking into sleep. Controlled, safe, peaceful. The cable passes through pulleys at various points. Pulleys guide the cable. Keep it aligned. Reduce friction. Each pulley is mounted on bearings. Bearings allow rotation with minimal resistance. The pulleys can turn freely, smoothly. The bearings are lubricated, maintained, inspected. Worn bearings are replaced. Everything that can wear out is monitored and replaced before failure. The motor room is protected, climate controlled, temperature and humidity regulated. Electronics don't like extreme conditions. Moisture can cause corrosion. Extreme cold makes lubricants thick and sluggish. Extreme heat can cause components to fail. So, the environment is maintained year round. Heating in winter, cooling in summer, dehumidification always, creating ideal conditions for the machinery. There are backup systems, a secondary motor in case the primary fails, a battery backup in case power is lost, manual controls in case the computer fails. Every potential failure mode has been considered. Every one has a mitigation. On New Year's Eve, in the hours before midnight, technicians run final checks. They test the motor, run it briefly, check temperatures, check oil levels, check electrical connections, verify that every system is ready. They don't test the actual drop, don't want to risk something going wrong, but they test everything up to that point. Verify that when the command is given, the ball will drop properly. And then, as midnight approaches, as the moment comes, someone pushes a button. Or maybe it's automated. The computer sends the signal. The brake releases. The motor engages. The ball begins to descend. 1,000 people watching in Times Square don't see the cable, don't see the motor, don't see the pulleys and gears and control systems. They just see the ball. Moving smoothly downward, steady, inevitable, beautiful. And a billion more people watching on screens around the world see the same thing. A sphere of light descending through the night, marking time, marking change, marking this moment they're all sharing. The mechanism makes it possible. The engineering makes it reliable. The maintenance makes it safe. But what people experience is magic, is wonder, is a collective breath held and then released. That's the beauty of good engineering. It disappears. It works so well. You don't notice it. You just experience the result. The poetry without seeing the mechanism that creates it. Your breathing is the same. You don't think about the mechanics, the muscles, the nervous system signals, the chemical exchanges in your lungs. You just breathe, and you're alive. Let yourself appreciate the systems that work without being seen, the infrastructure that supports experience, the engineering that makes life possible, and rest in it, trust it, let it hold you as you sink deeper into sleep. Every year, in the months before New Year's Eve, a team prepares the ball, tests it, makes sure everything will work perfectly when the moment comes. This preparation begins early. By September or October, technicians are already climbing to the ball, accessing it through the building, going out onto the roof structure where wind whips and the city spreads out far below. They wear harnesses, safety equipment, fall protection. Working at this height requires training and care. One mistake could be fatal, so protocols are followed, safety checks performed, every movement deliberate. First, they inspect the structure, looking for corrosion, stress fractures, any sign of deterioration. Metal exposed to weather degrades over time. Salt in winter rain can cause rust. Temperature cycles cause expansion and contraction that can create cracks. They examine welds, connections, bolts, everything structural. If anything looks questionable, it's addressed, reinforced, or replaced. No risks taken. The cable is inspected thoroughly, every inch of it examined. They look for broken strands, fraying, wear. The cable bears the ball's weight constantly. Stress accumulates. Eventually, it would fail, but it's replaced long before that could happen. Actually, the cable is probably replaced every few years. Better to replace it on a schedule than to wait for signs of wear. Preventive maintenance, cheaper and safer than reactive maintenance. The pulleys are checked, spun by hand, should turn freely, smoothly, no grinding, no catching. If a bearing is going bad, it's replaced. Better to replace a $10 bearing than risk the whole system. Let your eyes move under your closed lids, like pulleys turning, smooth, free, no resistance. Then let them be still. Rest. No more movement needed. The LED modules are tested, each one. Technicians work their way around the ball, activating each module in sequence, watching for dead LEDs, for color shifts, for any irregularity. If a module has failed, it's removed, a new one installed, the old one sent back to the shop for repair or recycling. The ball must be perfect, every LED functioning, every color accurate. The crystals are cleaned. This is delicate work. Crystal can be scratched, can be damaged by harsh chemicals, so cleaning is done with soft cloths, mild solutions, gentle motions, each triangle wiped carefully, inspected for chips or cracks. If a crystal is damaged, it's replaced. Waterford keeps spares. Replacements can be ordered and installed. Rare, but possible. The ball must look pristine, must sparkle, must catch light perfectly. As December approaches, testing intensifies. The motor system is run repeatedly. The ball isn't dropped yet, but the motor is engaged. Run at various speeds, tested under load, verified to operate smoothly. The control software is updated if needed. Bugs fixed. New features added. Maybe new light patterns for this year's celebration. Whatever changes are made, they're tested thoroughly, simulated hundreds of times. Every edge case considered. The lighting designers finalize their sequences. They have software that simulates the ball, shows what it will look like with different patterns. They can preview their designs, adjust colors, change timing, perfect the visual experience. They coordinate with the production team, with the TV broadcasters, with the event organizers. Everything must work together. The ball drop is part of a larger show. Music, performances, countdown. The ball is the centerpiece, but it's not alone. In late December, they do test runs. At night, when crowds are smaller, they might lower the ball part way. Not the full descent, not all the way to the bottom, but enough to verify that everything works. That motion is smooth. That controls respond correctly. These tests are unannounced. Most people don't even notice. A few curious onlookers might see the ball moving slightly, might wonder. But most of the city is unaware that up there, in the cold night air, engineers are ensuring perfection. The week before New Year's Eve, activity intensifies. The ball might be lowered to street level, fully lowered. This allows close inspection, allows any last-minute adjustments at ground level where conditions are easier. Photographers come, media crews, they take pictures, shoot video. The ball at street level is a rare sight, a chance to see it up close, to appreciate its size, its weight, its crystalline beauty. People might touch it, pose with it. It's a moment of connection. This object that they'll watch from afar, they can touch, can feel the cool crystal, the solid metal, can understand that it's real, substantial, not just an image on a screen. And then it's raised again, back to its position high above Times Square, ready for its moment. On New Year's Eve day, final preparations, everything checked one more time. All systems green, all backups ready. The control room staffed, engineers, technicians, directors, everyone in position. The city fills with people. The square becomes packed. Barriers control the crowds. Police everywhere. Media setting up cameras. Vendors selling souvenirs. The energy building. And up above, the ball waits, silent, patient, beautiful. Its moment hours away, but inevitable. Let yourself wait like the ball waits. No anxiety, no impatience, just existing in the present, knowing that what will happen in its time. No need to rush, no need to worry. Your body waits for sleep the same way, patiently, not forcing, just letting the natural process unfold, trusting that sleep will come when it comes, when you're ready, when conditions are right. And you're ready. You're so relaxed, so comfortable, so at peace. Sleep is close, maybe here already. Maybe you're dreaming that you're still awake. It doesn't matter. There's no difference that matters. Just rest, just peace, just gentle drifting. New Year's Eve. The final hour approaches. Times Square is packed, shoulder to shoulder. People have been standing for hours, in the cold, in the crowd, waiting for this one moment. The ball is illuminated, has been glowing all evening, colors shifting, patterns flowing, a beacon above the square, visible for blocks, drawing eyes, drawing attention. On the screens around the square, on television broadcasts, the countdown is synchronized. Everyone watching the same clock, the same timer, counting down the final minutes of the year. 10 minutes to midnight. The energy shifts. People start to pay attention, start to focus. The performances pause. The hosts begin the transition, directing attention upward, to the ball. 5 minutes. The crowd is getting excited. You can feel it. An electric energy, a collective anticipation. A million people all focused on the same thing, all waiting for the same moment. 3 minutes. People are counting, checking their phones, watching the screens, making sure they don't miss it. This moment happens once a year. You can't rewind, can't replay. Have to be present for it. 1 minute. The crowd starts counting. 60, 59, 58. Voices joining together. A roar building. In the control room, someone's hand is on the button, or the computer is counting down automatically. Either way, the moment is approaching. The systems are ready, have been checked and rechecked. Everything's green, everything's go. 30 seconds. The ball's lights begin their final sequence, the patterns accelerating, building, the colors intensifying, creating visual excitement, matching the auditory excitement of the counting crowd. 20 seconds. The host is counting with the crowd now. Everyone counting. Everyone's voice joining into one massive collective count. 10 seconds. This is it. The ball begins to descend, smoothly, steadily, the motor engaging, the cable paying out, the ball moving downward through the night air. 10, 9, 8. The ball descending, the lights pulsing. 7, 6, 5. The crowd roaring. 4, 3, 2, 1. Midnight. The ball reaches the bottom. The instant it touches down, the lights explode. Full white, maximum brightness. Every LED at full power. A sphere of pure light. Blinding. Beautiful. Fireworks launch. Confetti falls. Tons of it. Colored paper floating down like snow. Red and blue and silver and gold. Covering everything. Covering everyone. The crowd erupts, screaming, cheering, crying, laughing, kissing, hugging. strangers embracing, sharing this moment, this transition, this threshold crossed together. Auld Lang Syne plays, the traditional song. Should old acquaintance be forgot and never brought to mind, people sing along, swaying, arms around shoulders, connected, and the ball stays lit, stays bright, a beacon, a declaration. The new year has arrived. The moment has happened. Time has turned. For the technicians in the control room, there's relief. It worked. Everything worked perfectly. Another year, another successful drop. They'll celebrate later. For now, they're monitoring, making sure nothing fails in these crucial minutes after. But it won't fail. It never fails. Because of all the preparation, all the testing, all the care. The ball drop has happened every year since 1907, except for those 2 wartime years, over a century of tradition. Reliability built on expertise and dedication. Breathe in celebration. Breathe out joy. Let yourself feel the collective release, the shared happiness, even if you weren't there, even if you're just imagining it now. The feeling is real. The moment is real. Eventually, the celebration calms. People start to disperse, start to make their way home. The square slowly empties. Workers begin the cleanup, sweeping confetti, removing barriers, returning the space to normalcy. And the ball stays lit for a while. Then, gradually, its lights dim. The show over. The moment past. It returns to its quiescent state, hanging there, waiting for next year. The crew will inspect it tomorrow or the next day. We'll check that the descent didn't cause any issues. We'll verify all systems. We'll begin the cycle of maintenance again, preparing for next year, already thinking about what might need attention, what might need improvement. But tonight, the job is done. The moment delivered. Perfect. Beautiful. Shared by millions. This is what engineering is for. Not just building things, but creating experiences, creating moments, enabling connection, enabling shared joy. The Times Square ball is technology, is metal and crystal and light and motors, but it's also more than that. It's tradition, it's hope, it's celebration. It's a global community pausing together to mark time's passage. And every year it works. Every year the ball drops. Every year the moment happens. Reliable, dependable, beautiful. Let that reliability comfort you. Let the knowledge that some things work, that some traditions continue, that some moments are dependable. Let that ease any anxiety you might carry. The world is unpredictable. Life is uncertain. But some things remain. Some patterns continue. Some rituals endure. And you can rest in that, can trust in the continuity, can close your eyes and know that tomorrow will come. That time will continue. That life will go on. Your breathing continues. Your heart continues. The earth continues spinning. The universe continues expanding. All of it reliable. All of it dependable. All of it holding you. Rest in that holding. Rest in that continuity. Rest in the knowledge that you're part of something larger, something that continues regardless of your conscious participation. You can let go now, can stop following these words, can drift into sleep or into the peaceful space just before sleep, can rest fully, completely, without reservation. The ball has dropped, the year has turned, and you are here, safe, comfortable, at peace. Sleep now, rest deeply, and dream if you dream of light, of descent, of moments shared, of precision and care, and the beauty of things that work exactly as they should. Good night, but perhaps you're still here, still drifting in that space between waking and sleeping, still aware of these words, even if distantly. That's okay. There's no rush, no pressure. We can sit together a while longer in this contemplation. Let's think about what the ball really represents. Beyond the engineering, beyond the technical specifications, what does it mean? It's a sphere. The sphere is a perfect shape. Every point on its surface equidistant from the center, symmetrical in every direction, complete, whole, self-contained. Spheres appear throughout nature, drops of water, bubbles, planets, stars. The sphere is nature's shape, the shape that minimizes surface area for a given volume, the shape that's most efficient, most stable. Ancient philosophers thought spheres were perfect, divine. The heavens, they believed, were made of nested crystal spheres carrying the planets and stars, perfect celestial machinery. We know now that's not literally true. But metaphorically, there's something to it. The sphere as representation of wholeness, of completion, of perfection, aspired to, if not achieved. The Times Square ball is a sphere, imperfect, of course, made by humans with human limitations, but aspiring to perfection, designed with care, crafted with skill, as close to perfect as knowledge and ability allow. And it's made of crystal, transparent. Light passes through it, is transformed by it, emerges changed, multiplied, beautiful. Crystal has always been associated with clarity, with purity, with truth revealed. You can see through crystal, can see things clearly, no obscurity, no deception. The ball is transparent, but not empty, filled with light. Light generated by LEDs, by semiconductor diodes converting electricity to photons. Science, physics, but experienced as magic. Light is a mystery, a particle and a wave, both and neither, traveling at the ultimate speed, nothing faster, nothing more fundamental. Light is how we see, how we perceive, how we know the world. In religious traditions, light is often associated with the divine, with knowledge, with goodness. Let there be light, says Genesis, the first thing created, the foundation of everything visible. The ball is a sphere of light, descending from above, coming down to earth, to humanity, a blessing, a gift, marking a transition, marking time's passage, and time. What is time? We've thought about this before. Time as a dimension, time as an illusion, time as a measurement, time as experience. The ball drop marks a moment in time, midnight. The transition from one year to the next, an arbitrary boundary, a human construct, but meaningful nonetheless. We need boundaries, need markers, need ways to organize experience. Without them, life is overwhelming, a chaotic stream of moments without pattern or meaning. So we create time, create calendars, create celebrations, create rituals that mark transitions, that give shape to the formless flow. And in creating these rituals, we create community. The ball drop is something millions of people do together, watch together, experience together. For one moment, they're synchronized, part of something larger than themselves. In our individualistic age, such moments are rare. Most of the time, we're isolated, in our own heads, our own lives, pursuing our own goals, disconnected from others. But on New Year's Eve, for those 60 seconds, connection happens. Everyone watching the same thing, everyone counting down together, everyone experiencing the same transition. It's powerful, it's meaningful. Even if you're watching alone, you know you're not alone. You know millions of others are watching too, are counting too, are feeling the same anticipation, the same release. The ball enables this, is the focal point, the thing everyone looks at, the thing that makes the moment visible, tangible, real. Without the ball, the moment would still happen, midnight would still arrive, but it would be less special, less visible, harder to share. The ball makes the invisible visible, makes time's passage something you can see, can watch, can experience collectively. That's what good design does. Makes the abstract concrete, makes the conceptual experiential, takes an idea and makes it real. Your breathing makes life real, makes the abstract concept of being alive into the concrete experience of breath moving in and out, of chest rising and falling, of life continuing moment by moment. Let each breath be like the ball descending, slow, steady, purposeful. Each breath marking time. Each breath a small celebration of being alive, of continuing, of persisting. You don't need a crowd, don't need fireworks, don't need anything external. Your breathing is celebration enough. Your heartbeat is fireworks enough. You are the sphere of light. You are the moment of transition. You are the beauty. Rest in that. Rest in your own presence, your own being, your own breath. The ball will drop again next year, and the year after, and the year after. As long as there's a Times Square, as long as there are people who want to mark time together, the tradition will continue, and you'll continue too, breathing, living, experiencing moments, some moments you'll share with millions, others you'll experience alone, all of them valid, all of them part of your journey. Tonight, this moment is yours alone. No crowd, no cameras, no celebration except the quiet celebration of rest, of peace, of sleep approaching. And that's enough. That's everything. This quiet moment is as valuable as any spectacular public event, maybe more valuable, because it's yours, intimate, personal, real. The ball is beautiful, but so are you. The engineering is impressive, but so is your body. The moment is special, but so is this moment. Every moment, all of them. Let yourself rest in the democracy of moments, none more important than others, all precious, all fleeting, all exactly what they need to be. Sleep now, finally, completely. Let these words end. Let awareness end. Let conscious thought end. Drift into darkness, into peace, into the deep rest that restores and heals and prepares you for tomorrow. The ball has dropped. The year has turned. The story is told. Now, sleep. Rest. Dream of light if you dream at all. And wake renewed whenever that is. Whenever you're ready. Good night. Peace. Sleep.